All right, let's get started with talking about how to prove trig identities. First thing we need to talk about are, what are some of these identities? And identities are basically things that where we equate different forms of trig ratios to something else. For example, these first three we already know. We know that cosecant is the reciprocal of sine, so then cosecant is equal to 1 over sine. We know that secant is a reciprocal of cosine. That means that secant theta is equal to 1 over cosine theta. And the same thing with cotangent. It's equal to 1 over tangent theta. That's something that we already, well, you may have not have known that you knew, but you do know that. Down here, we knew number 4. We know from our unit circle that tangent theta is equal to sine theta over cosine theta. And since we know that cotangent is a reciprocal of tangent theta, then we know that cotangent is going to be equal to the reciprocal of this, which is cosine theta over sine theta. Now, some newer things. We have a Pythagorean identity. We got sine squared plus cosine squared is equal to 1. And then we have these alternate forms where sine squared is equal to 1 minus cosine squared and cosine squared is equal to 1 minus sine squared. All I'm doing here is, from this first Pythagorean identity, I've isolated sine theta here, which means I subtracted cosine theta from each side. And then here I isolated cosine theta, cosine squared theta, which means that I subtracted sine squared theta from each side. And then here we have a couple of more. Secant squared theta is equal to 1 plus tangent squared theta. Cosecant squared theta is equal to 1 plus cotangent squared theta. And then we have these double angle formulas that we'll be using also. The first one is sine of 2 times theta is equal to 2 times sine theta cosine theta. Now, don't get overwhelmed in the sense of, wow, we have to remember all this stuff. Well, after you work with it so much, doing all your homework, some of this stuff is going to come second nature to you. But for right now, don't even think about memorizing these identities. You'll be able to use your note card, and so we'll rely on this when we're going back and forth. Now let's talk about what we might do with those things. Some strategies for proving identities. Before I talk about the strategies, really quick, let me show you what I'm talking about by proving an identity. This one, number 1 here, it says cosine x times tangent x is equal to sine x. What we're going to do here is we're going to take one of these sides and we're going to use those trig identities on the first note card I showed you today, and we're going to try to convert that and make it look like the other side. Now let me show you some strategies to do that. First thing you might want to do is, using the established identities, in other words, what's on that note card, simplify each side of the identity we're trying to prove separately. The goal is to get each side equal to the same expression. The proof consists of showing a sequence of expressions, each one easily seen to the equivalent to its preceding expression. In other words, you're just going to take that trig note card with those identities and try to change one side or both sides to look like the other. Number 2 says do not skip steps. You have to show every step. In a proof, you show each step. You assume that the person reading the proof knows very little about it and you are taking them through each step. Okay? So if you skip steps, a person can't find or figure out what you're doing next. Number 3, we cannot add, subtract, multiply, or divide numbers or expressions to each side. So don't treat this like solving an equation. We're not going to be doing those things. We're not going to be moving things from one side of the equal sign to the other. Number 4, use the established identities to simplify the more complicated side first. Now this, number 4, this is something that is very important. There we go. Number 4 is very important. You want to look at the most complicated side first. Usually this works, and try to make it look like the more simpler looking side. Number 6, sometimes you might need a factor. And here's an example of if you had sine squared theta minus secant squared theta. This is the difference of squares. So that would be the first plus the last and the first minus the last. That's sine theta plus secant theta, and then sine theta minus secant theta. Okay. And sometimes we'll use some algebra to simplify, such as distribution. Like right here, we could distribute sine theta in here and have sine theta cosine theta minus sine theta, and so forth. Let's just do a few examples and let's see how this looks and how it goes. Having a little computer lag, so bear with me.